Tonight I'd like to thank our sponsors. And first of all, I'd like to thank the Goldman School of Public Policy for providing the room. Believe it or not, it's very difficult to get classrooms because there's such a demand. And so we are very grateful to the Goldman School for providing the room. And I'd also like to thank Carolyn Remick of the Berkeley Water Center. They provide the refreshments, and Carolyn handpicks everything herself. So, and I know that everyone appreciates having a little snack before the lecture at the end of the day. And I'd also like to thank our financial sponsors. Actually, the videotaping is one of the more expensive parts of this program, but I think it's very important to videotape each lecture because that way it really increases the educational component of the lecture series, and we put them on the web, and they're accessed quite a bit every year. We can't really get an accurate count, but around 40,000 times each year. And some of our, so the sponsors who pay for that videotaping and also some of the other costs associated with the lecture are the Earth Sciences Division of the Lawrence Berkeley Lab. Believe it or not, Metropolitan Water District is very generous and gives us some community partnering grants every year. The Vice Chancellor of the campus, the Groundwater Resources Association of California, the Beatrix Farrand Fund of the Department of Landscape Architecture, and the California Center for Environmental Law and Policy, which is part of the law school. So I'd like to thank all of our sponsors and turn it back to Matt to introduce our speaker.
Thanks, Linda. Well, it's a pleasure to welcome Brian Kluwer. Brian is a fluvial geomorphologist working for a federal agency which consists mostly of biologists, National Marine Fishery Service. Brian grew up in Idaho. He got an undergrad in geology at Idaho State, then went to Northern Arizona, master's, and did his PhD at Colorado State University. And he's been with NMFS in Santa Rosa now for 10 years. And it's hard to describe how important it's been to have someone like Brian in the agency to in-house have a really high-level understanding of fluvial geomorphology, so he can consult and work directly with the biologists in dealing with a range of issues which come up with fish and conservation. He's also then able to interact very effectively with other agencies and other stakeholders that are involved in the process. So he's worked on a wide range of topics, all involving important geomorphic components, but very relevant to fish habitat, gravel mining, river restoration, maintenance of infrastructure in streams, et cetera. He's also done a lot to convey the information or to get this kind of understanding into a form that is readily accessible by the staff in his agency and other agencies. So he's pioneered some tools that allow people to bring some of the geomorphic expertise to bear on the situation because there's only one of him and there are a lot of problems. So since we haven't figured out how to clone the guy, he's been working on these software packages and such that allow some of this information to be systematically applied. So it's been a huge, how should I say, breath of fresh air or improvement in the level of dialogue to have Brian at NMFS, and it's a pleasure to welcome him for this talk. Salmon, Orphans Without a Home, a Historical Perspective of Water and Landscape Modifications.
Thanks. Thanks, Matt, for that kind introduction. I'm not sure I deserve all of that. And I sure don't think I'm going to be able to solve all the problems, but there's plenty of good work for us to work on collaboratively, that's for sure. I'm normally not this red. So between windburn on Sunday and sunburn yesterday, and standing in front of a smart academic group like yourselves, if I look like I'm going to pass out, don't worry about it, I'll be fine. So in preparing for this, when Matt asked me to give a presentation here, it's a great honor, by the way, and thank you all for having me. And I said, what would be a good topic? You know the kind of things I'm working on: dam removal, gravel mining, restoration, tools for evaluating restoration projects, things like that. He said, why don't you just tell us what you think is wrong with the salmon? What's the problem? And that was actually quite a challenge for me. I'd never pieced it all together. And so you're the guinea pigs for some new GIS work and the story of habitat losses in the salmon landscape. And I want to thank our GIS specialist in Santa Rosa, Charlene Gavette, for all of her help in doing this analysis work and the maps. So this is a cartoon, but it's probably wouldn't be too hard to put some numbers on it. I think everyone more or less believes that this is the status of salmon, and they are hovering around in that less than, they're down in the single digit percentage population-wise from what their historic stocks were. And I'm going to piece together a story about habitat that ends up with the same conclusion, and I didn't expect to find that. It's probably a spurious correlation, but we can talk about it. So habitat status. Our technical recovery team, a group of federal as well as independent and academic scientists, put together this map, which is the outline of habitat for California. And I'm a lumper, not a splitter when it comes to biology. So I'm gonna use the word salmon, and that's gonna refer to coho, chinook, steelhead, and everything in between. And I don't need to distinguish between them for this talk. So historically, there's known to have been salmon, or there's the potential for there to have been salmon in this range, which is about 65 million acres in California. And you can see the areas that are marked out. It's the desert, of course. And that little, see if I can get the laser pointer to work here. That's the Carrizo Plain, I believe. And then, you know, that's a different watershed up here in the north. So, that's a large area. It's a big percentage of California's area, actually. And you're going to see a series of maps that build on this, this base map here. And I wanted to convey, with each increment of habitat loss, I wanted to convey a nice visual to go along with that, and it seemed like a speedometer or maybe a gas gauge was a good little tool. So I created this habitat area, percent area gauge, and we're going to start at 100%. That's 65 million acres. And with each successive loss of habitat, that gauge will go down. So a big loss, a big source of loss of habitat was blocking habitat. And we were very good at building dams. And the way that looks from a GIS analysis perspective is you've got a little watershed there, a model watershed in the upper left-hand corner, and you block that area away from salmon. So it's a very easy calculation. It's also pretty easy to put on the map, and it's pretty easy to quantify that, and it's incontrovertible. Salmon don't have access to that anymore. And that gets us down to about 80% right off the bat. The next loss is other dams. I probably didn't need to do two maps here, could have just had one, but these are smaller dams, maybe county and state versus federal might be a distinction. And we get a little bit more loss out of that, and we're down below the 3/4 mark for habitat. The next iteration of this is, you see the little habitat diagram there. Oh yeah, it's animated, great. And it shows, so in the red, sort of this beet red color is I've summed up the previous two slides, and then the blue, the new area, is a barrier within a hydrologic unit. So we don't have the data to split it down to subunits. We probably could put that together, but we didn't have the data to do it for this presentation. So this is a bit of an overestimate of area in this particular category, because it is just a part of the hydrologic unit is blocked. But it's not a partial barrier. That's coming up next. When we take that into account, this might be a bit of an overestimate, but we're sneaking down towards 60% now of the original habitat. And then there are partial barriers. There's depth barriers. This is an articulated concrete mattress over a utility line in a river in Southern California, a steelhead stream. And this is an example of a velocity barrier. It's a small derelict dam, hasn't been used for years, but nonetheless it sits in the watershed. And it, of course, is an orifice of high velocity water that fish can't migrate up except during placid flows. So a big window of migration opportunity is closed off to them. So that's a kind of partial barrier. And then there are falls, and we've got lots of those because California is kind of the epicenter of incised streams. So taking all of these partial and temporal barriers and putting them on the map and summing them up, we get another area, and that's the green. And that takes us now below 50%. So just due to those things which are physical barriers to migration, we've got less than half of our historic habitat left. Now this is the valley bottoms, and the brown, I guess that's brown, I'm a little bit colorblind. That color there, which reminds me something has to do with babies. That's area where there's diversions. And so this is out of the State Water Resources Control Board information. And I'll circle back to valleys here in a minute. And if we take that into account, of course, we don't have a heck of a lot left. We're really getting down to kind of the empty mark on a Prius. And I'm sure a lot of you drive Priuses. I'm a new Prius owner. And that collapsible gas tank's a real problem, isn't it? Do you think you've got 10 gallons? You go to the gas pump and you can only squeeze 7.8 in it, and you were on empty? Well, if that was your habitat meter, we would have gone extinct before we got to the gas station to refill. So we need a little bit of leeway before we get to the empty mark. And so anyway, I'm going to circle back to the valleys and diversions after going through. I have to show you urban areas just to show you that it's not a lot of area, and it doesn't wiggle our habitat meter more than about 1%. That was a little bit of a surprise to me. Now, I reverse that map. Let me back up. I'm going to reverse this map and show you what's left. So that's the yellow areas, what's left, and it's about 15%. 15% of the historic habitat. And I'm going to divide it between north and south, right, kind of along the line of where we're sitting. And there's a reason for doing that. In the south, a lot of these areas that show up as remaining potential habitat areas, I would argue really aren't. This is the dry side of the San Joaquin, for example. And this is the really high Sierras, which I don't think really should have been included within the historic habitat range to begin with. Those watersheds contribute materials and water to salmon habitat, but salmon didn't have access to them. So arguably we can take that out, we can take this out, and then this area here is the Salinas River. And there are numerous problems with the Salinas River, although steelhead do still try to make it up the Arroyo Seco. So right or wrong, I'm going to divide California in two, and the fish have kind of done that for us as well. Where the fish are hanging on today is up here where there's 6% of the historic habitat left in the North Coast. So we're going to zoom in on the North Coast a bit, and what really does this 6%, what are the other risks in this 6%? So I looked at, it's pretty much all forest land. So there's two colors here, there's private forest lands and federal forest lands. And you can see very little yellow that isn't in one of those forest lands. And on those forest lands, we know we've inherited a legacy of past logging impacts. Before we had mechanical power to move products out of the forest, we used oxen. Then we got the steam donkey. Maybe it should have been called a steam ox. I don't know why it's a steam donkey, but we could move, a man could move a lot more wood himself that way. And then of course right after World War II, we got Caterpillar tractors. And these things were really effective at moving lumber products out of our forests, but they still had to obey gravity. And so what they ended up doing was skidding logs down the streams. And pretty much every stream in our forested North Coast watersheds has a history of being a skid trail. And a trained eye can still see where the bulldozers and where the logs push sediment up in anomalous landforms on the banks, built crossings called Humboldt crossings, which were log decks laid down across the stream, and those things are still standing in places. Sometimes they're now passage barriers, but they haven't been removed. And then when they'd gotten all the commercial wood out of a forest harvest, the non-commercial wood would end up either because they put it there or because of storms and really poor drainage considerations, it would end up in the stream bottoms. And then I think there's a history, I don't have a slide to show it, but there's a history of the fish agencies promoting the removal of this wood, and then they got carried away, and now there's no wood left in any of our streams. We funded that too. So a lot of our restoration projects are involving putting wood back into streams, but it will probably never be at the frequency and the size and the effectiveness that it once was. And then this lower picture here is a poor quality one, but it shows an effect that we see in a lot of our North Coast streams, which is just an overwhelming sediment load in the streams. So the legacy of logging, there's also a future of logging. So this is just an example watershed, the Gualala River watershed, showing road density. And the blue lines are streams, and we'll zoom in on this one, it's easier to see. The blue lines, of course, are streams, and these are salmon habitat or potential salmon habitat. And where those lines turn black are where there's a road within, I think it's 200 meters, if we can read the legend there. Yeah, so that's where there's a road in real close proximity to the stream, and that is a future threat, if not an existing and ongoing threat to salmon habitat. So I feel pretty confident in moving my habitat meter all the way down to 6% in that forested area. And in fact, what this map shows is the areas that are protected in some kind of conserved land. So they're federal national parks, they're state parks, they're wilderness areas, they're lands that are conserved from timber harvest at least. And there's only one of these, maybe two, that are a complete watershed. And that's that one right there, which I believe is Redwood National Park. And this one here, which probably ought to come off of the map because it's the Jackson State Forest, and that's a demonstration forest. And I've seen turbidity and sediment results coming out of that land that rival any of those land conversions and other timber harvests that I've been involved in. So that's not a conserved area. So what we have on the map here for protected remaining salmon habitat is a bunch of fragments. They still have to run the gauntlet of whatever it is downstream from them to get to these habitats, these undisturbed habitats. And this is less than 2% of the original habitat. So our habitat meter really should be pegged out there, but I just couldn't quite make myself drop it to zero. We've got to have some kind of hope. Now I want to come back to the valleys because it's probably not fair, you would say, to subtract out all the area of the valleys from the historic habitat. And I would agree with you on that. But I did need to look into it further, and I'm going to show you my logic on that, and I'm going to end up defending moving the habitat meter to the left as I did before. So the question to me that I had to ask myself was, what were the historic habitats like before disturbance and settlement? And there's not anyone in here old enough to answer that question. We've been at this for a couple hundred years. So some of the earliest information I was able to find, I would love to be able to put a little bit more detail into this part of this presentation because there were some well-funded federal drainage, the Swampland Acts that were reauthorized several times. And this map shows that California is one of the top 6 states in the country for having taken care of more than 85% of its wetlands. And that comes out of the water supply paper 2425. So what were the history of valley modifications in the Central Valley? This is a view from about the Bay Area looking up towards Sacramento. I got it off of Google. And you can see, of course, that the Sacramento River is single-threaded and quite straight. You can see the Yolo bypass, which is exceedingly straight. And so there's been a lot of modifications to our stream channels. It's widespread. And frankly, I don't think I've found any stream channels in my 10 years here that weren't either channelized, levee-lined, or incised because of some management action. I can't think of any undisturbed stream channel that has any length to it. And I wish I had a similar map from, or photograph from California, but the same process went on all over the US where there were wetlands. And one of my formative experiences growing up in Idaho, I grew up on a farm, and when I was about 12 or 13 years old, the Soil Conservation District rep came to our farm and asked my dad if he would like some money to straighten the stream that crossed our property. And it was the last stream, it was the last segment of that stream on our valley that hadn't already been straightened. And, you know, who could turn that offer down, right? So we spent about 2 weeks. We hired a bulldozer. We straightened that stream just as straight as it could be. We took out its meander bends. And it was, previously we'd fenced it off from the barley and alfalfa fields that were right next to it. And it was an area approximately 22 acres. It was 3/4 of a mile long. And when we were done straightening it and moving the fences so that we could gain that little bit of extra arable land, I think we got 12 acres out of it. So we got about half of what we had previously set aside behind fences and just let it be wild. And within 2 years, that stream had incised 4 feet. In 2 more years, it incised 6 feet to 8 feet. And the water table dropped in that 400-acre field, and we could no longer dry farm. So that was my first introduction to engineering and fluvial processes, and it was important. It probably explains my interest in this stuff today. So this is actually a great little quote to just read, because it tells us what happened in the Central Valley because of the swamp and wetlands drainage acts. And the numeric details here at the bottom, it says prior to the mid-1800s, the 13 million acres that made up California's Central Valley, 4 million of those were estimated to be wetland. Well, that's a pretty high percentage. And I don't have a comparable figure to go with that today, but I'm sure we could come up with it with a little bit more work. So how did we do that? It's pretty easy. You've got a series of meander loops. You just take some heavy equipment and you cut off those loops, or you can fill them and you can excavate a shortcut between them. And we did this all over the country. This is a photograph from Oregon just because I happened to take it and I like using my own photos when I can. This happened all over California, all over the Central Valley, anywhere we had an alluvial valley and a wandering stream. There's some new interest, maybe new science. I'm not sure if it's really reached the level of science yet, but perhaps the earliest disturbance to our landscape was the French beaver pelt trappers. There was a big market for beaver pelts, and there's very few records of that. But beavers can be quite a dominant fluvial influence in a low gradient system, and we know that they work that way today where there are large numbers of beavers, and there's evidence that there were beaver in the valleys in California, although many people dispute that. We can ignore that if we need to feel good about it. What I do have some numbers on, the disturbance numbers from a section of the Russian River near where my office is. This is just upstream from Healdsburg. And on the left, the photo is from 1942, and we mapped out the active channel area, the riparian area, in this short segment of, it's less than a mile. Well, it's about a mile long, it looks like, 2,600 meters. And it was 750 acres. And after the federal flood control project came through, it's now 364 acres. And its edgewater habitat is probably a third, maybe even a quarter or even less of what it once was. So we've gotten ourselves into the era of river management, where we have virtually nothing left but artificial channels that have been straightened, have only the narrowest riparian corridors on them in most cases, and great lengths of them have already got revetted banks on them. So they're not real high quality habitat. And then culturally, I think we have unreasonable expectation for them to be stable. These are, after all, dynamic, rivers are dynamic systems that respond to watershed processes, to climate change, to El Nino cycles, to sediment delivery, sediment sorting, and they do that by meandering and by depositing and sorting sediment and eroding. And so what we have is artificial channels and lots of cultural conflicts with them, and we fight those conflicts locally with bank protection and stabilization measures when most of the time those processes are watershed scale processes. So we're fighting at the wrong scale typically. But it's great make work. We just keep doing it over and over again. And I'm going to show you some of my most fun examples of some of the silly things we do to rivers. This is, again, is a piece of the Russian River upstream from Healdsburg. It's flowing towards us, or down, flowing towards the bottom of the slide, I guess I should say. And that's a pilot channel that was excavated across the bar. And on river right, which is over here, it looks like there's quite a lot of space to accommodate that river meandering. But you know, for some reason, the property owner didn't want it to do that, so they excavate a pilot channel through here that will pirate the flow during the next storm event and straighten it out and expedite flow. And they feel like it reduces the migration rate towards their bank, and it probably does for a little while. Salinas River is a good example of what we've done to our streams. You can see the meander scrolls in the soils still, even though it's row crop, 3 rotations a year. You can see the terraces on the banks. Here's a high terrace on one side, and here's the terrace on the other side. And in between, this was all active channel. And this is now the managed Salinas River doesn't even have a riparian zone on it. It's got 1 row of trees, but that's just a windbreak. That's not there because of the river. And that river, of course, deposits its load in very inconvenient ways. And because it has water year-round, it grows vegetation in inconvenient ways. So it's really easy to take bulldozers out there and just go back and forth. See those tracks? Pretty much the entire width of the channel has been reworked to get rid of the vegetation. And they also shove a little bit of sediment around it, sand. And they'll move, say, a 4-foot high bar. They'll be able to dig that maybe about 1 foot deep while they're pushing it in one push with the bulldozer. And they feel like that gives them increased channel capacity. And anyone who knows about sand and sediment transport knows that when you liberate that much sand, you're going to get bed forms that you didn't have before, which is going to give you roughness coefficients you didn't have before, and water level. We've actually done HEC-RAS modeling on some of these projects and show that there is no improvement in flood conveyance capacity. Also, if it's flowing in this direction here towards me. If you're the landowner just downstream, you shouldn't be very happy about this amount of sand just now being liberated for the stream to pick up and move in the next flood, because it's going to move right into the next zone. They didn't have the vegetation removal, and it's going to accumulate. And your flood capacity is going to go way down. So we manage our rivers very piecemeal in this artificial setting. And so we sort of maximize our conflict with them. Another one of my favorite topics of the silly things we do on the landscape is alluvial fans. And not everyone recognizes that California has alluvial fans, but we do. They often have some of our densest urban areas on them. Or in this case, grape orchards, or not grape, these are orange orchards. And this is Santa Paula in Santa Paula Creek. You can actually see this from space. This is a big project. It's a sediment settling basin that was excavated across the alluvial fan. And the idea was it provides some sort of flood control to these. You can see the predominant streamside land use is oranges. And so the idea is sediment loads will drop out in this basin, and they won't drop out at such a rate that you lose flood capacity, but you'll be able to go in after storms and excavate the sediment out and haul it off to Lord knows where. I don't know where you take sediment nowadays. You can't put it in the marketplace. That's illegal. What do we do? Do you know what we do with sediment that we excavate out of projects?
Well, this happened like for LA County. They used to sell or provide the sand and gravel for the construction industry, have it of aggregate. And because the aggregate producers objected, it now goes to a landfill.
That's it. Yeah. So if we're lucky, that landfill will be upstream, and we'll get to do this over and over and over again. Call it a stimulus project or something. So this is a really big project. It's hard to see the scale. So I've got some, this is the pamphlet, and there was a ribbon cutting ceremony. This was a $10 or $12 million project to build a fish ladder at the head of this, this sediment collection channel, which was, in geomorphic terms, what they created was a head cut, a 20-foot high head cut at the upstream end of alluvial fan. Well, that's a pretty risky setting in a pretty high energy environment. It's probably never been done before, but that didn't stop them from doing it. So here is the fish ladder. And to give you an idea of scale, each one of these weirs, you can see all the steel for each one of those weirs. You see the truck and the crane. This is a big project. This is a very big facility. And after one storm, the fish ladder is completely destroyed. The channel is flowing adjacent to the fish ladder, not over the fish ladder. And fish can't pass it because this is a smooth gunite bottom, concrete bottom on the channel, and it's supercritical flow velocities. So it's still a fish passage barrier. So about 2 million more were put into that to repair it, clean it out, and repair it, and it lasted 2 more years. And now this is one of the top stimulus projects. There's 12 to 14 million more going to go into the third iteration of this, and my prediction is it will last 1 more storm. Now, what about stream flow modifications? So far, I've just talked about the landscape. We got to talk about water too, because I think fish need both. And there's this great paper. I'm not sure I suggested you read this one. It probably wasn't on the list, but it's by Charlie Luce and Zach Holden and their Forest Service hydrologists. Charlie's in Boise, Idaho, and Zach Holden's in Montana, I think. And they looked at gauges, long-term gauging records across the Northwest, Idaho, Montana, Oregon, and Washington. And they found a very consistent declining trend where, I think I just quoted it here, yeah. The drier years, the drought years, are getting drier. So it's a consistent signal that our droughts are getting deeper and longer. They didn't attribute that to anything in particular. They left it vague and open because they are probably wanting to do some more research, more funding on that. But it could be climate change, it could be water development, it could be a combination of both. Well, we've got a little bit of information close to home to look at trends over time. And the Navarro River watershed and the Russian River watershed, I could gather up some information on. And so we've got plotted on here all the different colors from the previous maps. So, for example, this part of the watershed is blocked by a big dam. This part is blocked by a big dam. The blue, of course, is a block of part of the watershed or a partial barrier. The black is an urban area, and the brown is areas where there's water diversions. And the red dots are points of diversion, and these are surface water diversions. And these are just the ones that are legally cataloged. The State Water Control Board has told us recently that they think there might be nearly an equal number of illegal diversions out there. And this map is just the Russian River basin, and what I've added to it is the streams. So all the squiggly blues are the streams. and the green areas is vineyards. And these yellow dots are high volume direct diversions used for frost risk pumping. And I'll show you a little bit of the effects of this novel new thing called frost pumping. And what it is since the 70s and 80s, vineyards have moved out onto the valley bottoms and replaced orchard crops, food crops. This is now wine grape crops. And they manage for frost risk with overhead sprinklers. And they, you can imagine, it'd be kind of like a brownout if everyone went home and turned on all your appliances at exactly the same time tonight. You know, you might brown the grid out, the grid might crash just because it can't meet the demand. Well, that's about what goes on here. When there's a frost risk, every pump in the basin could go on at once, and we can see the signal in the Russian River. So it is flowing at over 200 CFS, and when there's a cold morning, anything below about 35 degrees seems to be the threshold signal for turning the pumps on. The flow in the Russian River can drop nearly 50% instantaneously. Well, not instantaneously, but within, a very short period of time, 1 or 2 15-minute measurement cycles. And we've known that this is a problem for years. We've never had the manpower to go out and really look at it systematically. But one of our biologists did go out in 2008 during this event, the big one here. And he found, I don't know how many fish, but he found a lot of salmon fry stranded on gravel bars. So if you can see a signal like that in the Russian River, imagine what might be going on in the tributaries. And Matt Deitch is in the audience. This is his work. Deitch, Kondoff, and Marylander. And he looked at some tributaries to the Russian River. And he sees the same thing, where when you have the red dots here are temperature, and I drew the 0 degree threshold in here. You can see anytime you approach 0 degrees, the stream flow takes a precipitous drop. And those are changes in discharge of over 50%, it looks like. And here's a nice quote from Matt's paper. And essentially what it does is just accelerates the dry season condition. It brings it on earlier and maybe makes it deeper. And I've plotted 2 recession lines on there just to illustrate what that means. The black one is how the stream flow might have receded without these frost events, and the red line is how it did recede because of pumping out that extra volume of water when it's in a pretty low flow condition already. David Hines, who's in the audience, he and I have done some work elsewhere in the Russian River Basin, and we're seeing this signal in lots of different places. So we think it's a pretty widespread phenomenon that lines up with, I'm going to back up at the risk of all these, that lines up quite well with what we see on this map, where the yellow dots are on top of the green fields. So, sorry about that. Now let's look at the Navarro River a little bit. Jim Hunt sent me some information about a year ago that is pretty interesting as well. It corroborates what we're seeing on the Russian River. And I just pulled part of it out to show you these graphs this evening. But what I want to point out is over here on the left is recession graphs in the 1970s, and over here is recession graphs more recent time, just a few years ago. And on the table are volumes, annual runoff volumes. And you can see that the driest year was 1977. It was just 21 millimeters, and it's got an anomalous recession rate and depth as well. But look at 1976, for example. It was, what is that, 111 millimeters? And that crossed at about day 290, water day 290, it crossed the 10 CFS line. If we come over here 30 years later and look at flows very similar in volume, we see that they're crossing they're crossing the 10 CFS threshold well before day 290. So I'm concluding from that The existing water development has created perennial drought conditions. So, habitat losses. We've been modifying habitat for 2 centuries here in California. Much of it was by well-funded government programs. I would love to do some follow-up work and do the accounting on those programs. I'd like to know how much money was spent on these channelization, flood control, drainage programs. I think that'd be a very interesting story, and it might give us some guidance on perhaps the future cost of restoration. And I'm surprised by this, and maybe I'm just a Pollyanna, but I think the extent of habitat loss is much greater than the public realizes. I think it's much greater than the scientific community realizes. And that leads me to state that restoration has not been at the same scale of habitat loss. It hasn't really even come to grips with the scale of habitat loss. Now, to add to that, I'm going to hand out razor blades here in a minute. It's only going to get worse. We're just now learning what salmon need, which is pretty shocking, but I'm going to show you what I mean by that. So this paper came out in 2003. It's about how beaver dams, those geomorphic influences that they are, coincide with fish habitat. And there was a follow-up paper by the same lead author in 2004. And of course, this is from the Northwest, and people in California don't necessarily embrace any science that comes from elsewhere, but there is evidence that beaver were in California. And the thing about this graph here is that the upper, so what's on the x-axis is size. It's the size of fish, just in millimeters, real simple measurement. And you can see that the greatest number of fish in the outside of beaver ponds is quite small. It's like in the 30 to 40 millimeter size. And in the beaver ponds, the greatest number of fish in this 70 to 80 millimeter size. Well, size is everything if you're an anadromous fish heading to the ocean. And this concept is backed up in some more recent paper, 2006, that shows the influence or the value of floodplains. And here's a quote from that paper. It says, the annual inundation of floodplains is the principal force determining productivity and biotic interactions in river floodplain systems. And the last part down here, but this has received little research attention. Then here in our backyard, Carson Jeffries et al., 2008, show us the difference in growth rates between fish that have access to a floodplain and fish that don't. And then this paper really brought it home for me, maybe because I know these guys. They're at our Southwest Fisheries Science Center in Santa Cruz. And I'm more likely to talk to them than I am the other fish biologists. But they looked at seasonally closed estuaries or lagoons along the south coast. And their graph here shows us that same trend, that fish rearing outside the lagoon get to about 100 millimeters. Fish rearing in the lagoon get to be nearly twice that big. And here's a great quote from that study. Provides compelling evidence for the importance of estuarine habitat as a nursery to coastal steelhead populations. And they conclude also that this effect was previously unknown. So it boggles my mind, but it leads me to say that we've recognized for less than a decade the importance of out-of-channel habitat for salmon. We've been focusing on in-channel habitat. And in fact, salmon are floodplain wetland species. I think that's novel. There's also growing evidence that historically, multi-thread channels were widespread, and our paradigm is a single-thread channel, and Matt talks about that a lot in his work. So how have we responded to the habitat losses? One way I can look at that is to review where money's been spent on restoration programs. And here's a table current up to 2005. And it looked at nearly 7,000 projects. And I think it accounts for about $2.5 billion worth of public funds. And I'll highlight the biggest expenditures here. 50%, more than 50% of that money has been spent on a category called stabilization. It's bank stabilization, 9%. Riparian planting, 8%. In-stream habitat enhancement, 13%. Road work, watershed improvements, 21%. And what really stands out for me is water conservation, 0.2, and this is rounding up, of course, and habitat acquisition, or land, 0.1, and that's rounding up as well. So we've spent the majority of our money maintaining our damaged and not particularly productive habitats, and we haven't really even, according to where we spent the funds, we are surprised that salmon require out-of-channel habitat and water. So what will it take? Space and water. And I want to leave you with some reason to not go home and slash your wrists. So we are doing a few interesting things that are valuable. Remove the barriers. We know the barriers were a big part of the habitat gauge dropping off right away. A lot of dams have run their course of usefulness. They're a nuisance on the landscape now. There's no reason to keep them in place, and some of them are safety hazards. And we are beginning to remove some big dams, and those sometimes do open up big portions of watersheds that were previously inaccessible. This is Savage Rapids Dam on the Rogue River. And there's Marmot Dam on the Sandy River. Here's Savage Rapids again. I don't know why I showed it twice. We need to reconnect wetlands and floodplains. Giacomini Wetlands is a good example of that. That's, I think, 200 hectares. It's a big project. That's enough space to really be productive in that watershed. And that was done with construction equipment and just removing levees that had been there for I don't know how many decades.
Where's that located?
Point Reyes is the village. Yeah. We need to give rivers space. We are doing some river re-meandering work, but a lot of these look like, engineers that got a flexible rule instead of a slide rule. And unless it comes with a really aggressive riparian planting and management scheme, it just adds a little bit of length that may not add a lot of value. But we are doing some of that. But I think water's the key. We've got to really get serious about how we view water, how we manage water. And there's a nice little example. I'm going to back up. That's the village of Bodega, and this is Salmon Creek. And not to be confused with Bodega Bay, but Salmon Creek does flow out to the coast near Bodega Bay. And this little bucolic village is the recipient of a $1.54 million stimulus grant to, I'll just turn them all on here, conserve water, to budget and allocate water, and replace direct diversions. The municipal water district here pumps its summer water for only 60 customers, I believe, right out of Salmon Creek. And this is salmon habitat, but it dries up in the summer. And there are lots of examples of that where there is some habitat, but it's not persistent year-round because in the rural residential, as well as just these small urban areas in the Mediterranean climate, the summer flows are really low. And you've only got to drop it a little bit to cross that threshold between having water available for fish and having a stream bed that you can walk on. And this project intends to harvest roof water rainfall, store it in tanks, and use that during the summer, coupled with an agreement to turn off the pump from the stream at the same time. And it's got a monitoring program to go along with it. And this map is a very interesting thing. David Hines and a few others and I put this together last year for the AFS conference. And what it shows is the potential for a 1,500 square foot roof. I'll bet all of you live, well, some of your students, but you know, I live in a home that's, I don't know, probably a 2,000 square foot roof. So 1,500 square foot roof is probably smaller than the average. And it shows the ability of that roof, given California's average rainfall, to deliver to you 100 gallons of water a day. And it's color coded. So You can see the deserts over here in red. They're not going to produce much water from this scheme. But the scale is the number of months that your roof can meet your needs. So anything in this, just starting to get into blue, what are those numbers? That's 9 to 10 months, right? Yeah. And anything lower than that, anything more blue than that, is more than 12 months of your needs. So it's more than 100% of your needs. And you see vast areas in California produce more than your potential needs, just off of a 1,500 square foot roof. We'll take questions here in a minute. We're just about done. So this project in the village of Bodega is a demonstration project. Its intention is to show that this ancient technology can work and can even be effective for increasing stream flows in the stream. So I'll summarize here. I think what we need to do is first recognize the scale of the habitat loss. And then we need to respond to the loss of out-of-channel habitat in particular. Salmon are out-of-channel, they're wetland species. And then, of course, we're going to have to fund, legislate, conserve, and restore appropriately. And these are just my data sources for the maps. So I'm sure there's plenty of time for questions. You had your hand up. Yeah.
Okay, please wait for the mic to, so we can get your question recorded on the tape.
I'm curious what be productive in the wetland means. What are the fish actually doing in the off-channel?
It's a foraging opportunity. So it's just an opportunity to feed on a rich food source that isn't otherwise available. We held a symposium about a year ago in Santa Rosa on the idea of reconnecting floodplain gravel pits to the Russian River. And one of the theme topics of that was, what are the feeding opportunities in the off-channel environment? And we found some scientists from Oregon State University, as well as our Science Center lab, who were very excited about very brief off-channel feeding opportunities, even as short as a week long, that made the difference in growth rate for salmon to then be able to go to the ocean and survive and come back. What I didn't point out is in those histograms of growth rates is that there appears to be a threshold size where if they don't get to about 140 millimeters before they go to the ocean, they're not likely to return. And without that off-channel opportunity for forage, they don't get to that size.
Do you have to worry about larger fish that live in the off-channel ponds? If you reconnect it, then they eat the little ones?
Yeah, I think fish are predatory. You know, that's a two-edged sword that we fight with internally all the time. Is it worth losing a few fish in order to benefit the population? And I think we're just now being able to ask that question. Yeah.
I'm still waiting for my razor, by the way. You had me in tears a few minutes ago.
Don't do it. It's not worth it. We need your help.
So two sort of related questions. To what extent are the restoration projects as compared to being permit and funding projects or preservation of bureaucrats as opposed to preservation of endangered species? And with the CCC having been integral in building dams during the last depression, when the next depression hits, after we've spent all this money taking away the dams, are we just going to go back and build them again? Is this just sort of a cycle, a human cycle? That's my question.
Well, I'm not very good at crystal balling. I think you answered your first question yourself. Yeah, we do sort of promote the status quo, don't we? It's a hard thing to break. And building more dams, I know we're talking about that. Society's talking about that because we recognize we have increased need for water. But I showed you the map of just capturing your own roof water instead of putting it into the storm sewer. The potential is huge. But we do need to tackle the institutional impediments that keep us from doing those common sense sort of things. So distributing water supply instead of concentrating it should be our new paradigm. And the legal mechanisms don't really promote that. But I don't think there's any reason why we can't do that. Next question.
So I'm hoping you can sort of expand your comments a little bit more about the importance of estuaries and seasonally closed estuaries in coastal California in particular. And I just find that different, sort of seem to be some conflicting ideas about how best to manage these coastal lagoons that seasonally closed. And you see certain people arguing that they need to keep the estuaries closed, and other people going out there with shovels and trying to open up the estuaries for the fish. And there seems to be a lot of debate over sort of what would be best for the fish. And I think there's different estuaries in different states of degradation. And it seems to be sort of a complex issue. I'm just curious to hear what you
You look
about
familiar.
that.
Have we talked about this before?
Perhaps, yeah.
It is very complex, and there's a culture of breaching sandbars because it's a lot of fun. You know, I watched a woman take her 3-year-old son in a plastic shovel out to the barrier bar at Redwood Creek in Golden Gate National Recreation Area, and they worked for a couple of hours, and they dug a little trench, and they got that thing to breach. And we know there's coho in there. I've been at the beach at Carmel on the Carmel River, and I've watched surfers go out there with their surfboard, the pointy tip of a surfboard, and just start scoring a track across the beach. And they do that 3 or 4 times, get 3 or 4 guys doing it 3 or 4 times, and when the lagoon is at a really high level and the tide is at a really low level, you've got this tremendous head across that beach, and it starts to rush, and it creates a channel that is a lot of fun to watch, but it flushes the lagoon in literally, less than an hour. So there is a lot of debate about how to best manage them and their value, and the 2 schools of thought that I've encountered are the closed lagoon, given enough inflow of water and enough time, can convert to a freshwater lagoon from a saline estuary. That freshwater condition favors food sources for salmonids. The other side of the management scheme is if you keep it open so that it receives, and let me back up, in that conversion process, it may not really favor any species. And so it may take a few weeks, it might even take a month for that conversion process to go from being a productive saline environment, brackish environment, to a productive freshwater environment. So the other way to manage is to keep the bar open all the time so that you never have that conversion period and it is just a brackish environment all the time. And I think some groups have used something called an indicator of biological diversity to justify keeping it open because they find a greater diversity of food species, but they may not find a greater abundance or an abundance that favors salmon. So the research I showed you from Bond and Hayes at our science lab, that's from Scott Creek, and that was a freshwater lagoon that had beached up on its own and converted to freshwater. And we're involved in the management of the Russian River, the Carmel River, and everything in between, which have a long tradition of flood control interests, keeping them breached all year round. And in the Russian River in particular, it rarely has that 2-week to 1-month period of time to convert from one productive habitat to the next. It's constantly in this less productive flux. And what we're promoting is more stability. Yeah.
Okay, first I'd really like to thank you for an outstanding illuminating presentation and for your focus on natural floodplain watershed function as a really important part of restoring ecological health to our systems here. So that was really fantastic. Now I'm going to put you on the spot a little bit, though, and this may be a difficult question for you given your professional affiliation. I know you're not a spokesperson necessarily for your organization, but California is going to be grappling with an $11 billion bond package this fall for the Delta package. You know, you've talked earlier in your presentation about the amount of money we spent not always going the right direction with our watershed riverine projects. Can you help us better understand how well that package addresses these natural functions, and if you think it will restore the kind of function and health we need in our systems?
Well, you can't put me on the spot on that because I don't know what's in that package. I have no idea. I'm not involved in that.
Okay.
Sorry.
You mentioned that water, it keeps coming back to water, and in my experience, it's taken us a long time just to get to the point where direct take of stranding these fish on a bar is something is being done about that. I'm wondering if you can prognosticate about how long it's going to take before we actually get to a standard that protects fish throughout their whole life history, where there are standards for proportion of the natural hydrograph that are provided to streams, or else, kind of what's it all about?
Yeah.
Unless we get to that.
Oh, I think we have a lot of work to do. That if we go back to the Russian River as our example, a lot of people feel like it's over-allocated already and needs an adjudication. And that's a lengthy, state process for assessing the water resources and the water uses and reallocating in a more appropriate fashion. I think we're going to have to do that all over the range of salmon. How long that's going to take, when we're going to do it. We've got a water rights program in my division, and he's sitting right there. It's one guy. So we're pretty understaffed in that resource area. But you know what is quite effective is, for example, stranded fish. We're only a few eyes and ears that can go out and look around. But when the citizens call and say, hey, we've just spotted something out here that's bad, we'd like you to come and take a look, those calls get responded to.
It seems to me, you showed in your early map that the impact of urbanization is actually only about 1% of the habitat. And yet you said, well, we need to have more rainwater harvesting from roofs and stuffs.
Yeah.
And then you showed some images of dams and barriers being removed. Mm-hmm. So it seems to me that the biggest challenge, the biggest benefit is, rainwater harvesting is great in urban areas, but it seems to me that the biggest benefit is going to come from removing those barriers. So that led me to remember what we talked about here last month, which is the agricultural uses. And it seems to me that all those barriers were put in place for agricultural uses.
Yeah, a lot of work.
So that brings us back to the question of where's that water going for non-urban. So anyway, I'm just putting that out as a comment, a question.
No, that's a good comment. There's lots of different ways of looking at our water use. But I'll come back to, we need to get really serious about conserving, budgeting, and allocating. It's a finite resource. And then replacing direct diversions, because they have a direct impact. And this photo is actually worth looking at again. This is a rural residential watershed. It's got just a couple of little tiny urban centers. The village of Bodega has 60 people or something living in it. And each one, it's got a couple of dairies in it as well. So there's your ag use, and they're big water users. But in this Mediterranean climate, when every riparian landowner has a little pump in the creek, the cumulative effect during the dry season is huge. And in my promoting roof water harvesting, rainwater harvesting, I think can offset the rural residential uses. And in these coastal watersheds, it can make the difference between having dry habitat in the season and having wet habitat. So urban areas, yes, there's a lot of water use there, but maybe there's not a lot of impact because those areas are usually served by a municipal water district that might be well managed in terms of its impacts. These rural residential individual water users don't have those same sort of standards. And the cumulative impact is, it's just so hard to measure. Yeah.
Has anyone ever analyzed how much of land is available to be opened up for out-of-channel habitat without necessarily endangering human settlements?
I know there's, I can't answer that in the round, but I know that there's some proposals to reconnect floodplains on the Sacramento River, for example. The CalFed process has looked at some pretty large areas of floodplain that could be reconnected. And I don't know what those, what those figures are, but I'm sure they're pretty large. Matt might know what the numbers are, but no one's done a systematic analysis of it that I'm aware of. Yeah.
I found this absolutely fascinating. Obviously, your focus is on salmon, but I'm thinking of these watersheds, these lagoons, these closed or floodplain habitats. Can these be combined with other kinds of aquaculture? Or is the salmon to be treated as such a special kind of iconic species that it's impossible to think of multi-species uses of these areas? You see what I'm getting at here? That it seems to me the possibilities here of meeting many different priorities is enormous once one gets beyond the kind of riverine fetishism and gets to this idea of the wetlands or the floodplain.
Well, if I understood your question properly, wetlands, floodplains do benefit lots of different fish species. And the research from the folks at Oregon State University that I'm familiar with shows that the timing between salmonids and what we consider to be their big predators, the bass and other things, those are warm water species. The timing is different such that there's not much conflict in the same environment between salmon and the big voracious warm water species that would prey on them. And one of the outcomes of that symposium on floodplain pit reconnection was an examination of our idea of that predator-prey interaction. And what we found was that there really isn't science to support that management paradigm that we can't let salmon be in places where there are bass. That's just an idea that is perpetuated through management.
Yes, you talked about the frost spraying that the vineyards do. Is there any alternative to that, or are there any proposals for regulating that?
Great question. Yes, there are alternatives to there are a number of frost events each year, typically, and the greatest number of frost events occur in drought years. So you can imagine the conflict that creates. You've got an industry that wants a lot of water, and you've got streams that are in drought condition, and fish are caught in the crosshairs in that condition. And that's what happened in 2008, but it surely will happen again. The options for the wine grape producers are, keep in mind this is a relatively new and novel use of water in this industry. The generation before, the parents of the people that, well, I don't know if there are any family wine grape producers out there anymore, but the generation before didn't grow grapes on the valley bottoms because they're prone to frost. They knew that. Well, we know it too, but we had to go through a whole exercise of mapping it out and verifying the model, and people are still arguing over the model, where the model's right. And there's just no common sense. Because sprinklers are readily available now, that's just taken for granted that they'll be installed and they can manage frost risk on frost-prone areas by spraying water at will. The options to that are take some frost damage is one of them. You don't lose a whole crop with a frost, typically. You lose a percentage of it. I know there are really deep frosts called advective frosts or something like that that might wipe out a whole year crop. But I think there's been excess production of wine grapes the last several years anyway, so they're overproducing and they're not even picking all of their crops. They're letting it sit on the vines. So one option is just take some loss. and not use so much water. Another option is wind machines. They can be quite effective for some kinds of frosts in some locations. Crop insurance is probably a very inexpensive and viable option everywhere. Are there other options that I'm forgetting, David?
You can plant different varieties.
Oh yeah, there are different varieties of grapes that are less frost sensitive. And I'm not sure if I have this right or not, so please straighten me out if I say it wrong. But it's my understanding that the current preferred varieties they're called varietals. You know, they have small, unique names, and they're more sensitive to frost than more robust kinds of grapes. And I'm not sure if whites are more sensitive than reds, but there is some difference there. So it seems like what they've chosen is the most sensitive grape varieties in the frost-prone areas.
And if you have to do frost protection, you can store offstream.
Yes. Yeah.
Pull out of the pond instead of pulling out the stream.
Yeah. Budget and allocate. I should have mentioned that.
My question is, in one of your slides, you showed an example of the Russian River where you said the landowner had gone in and straightened the channel. Mm-hmm. And I'm interested in that particular example, but also the broader question of how the partner state agencies that are supposed to regulate these kinds of things, like Department of Fish and Game and California Department of Forestry, because you mentioned all the forestry lands that are under regulatory regulation by these agencies. How are they doing in performing? I just can't imagine that today a landowner is allowed to go and channelize the Russian River. Is that the case, that they can get a permit from Fish and Game to alter in-stream flows?
That was probably done without a permit, and it would probably be done again without a permit. You know, the fines are just not big enough to worry about.
So you're saying that perhaps our partner agencies that are supposed to regulate this type of behavior are not really doing a good job?
Well, I'm not going to let you put those words in my mouth, but we've all got a lot of improvement that we need to make. You know, for example, very close to that photo I showed you where there was a pilot channel excavated through that bar, there was an emergency drop of, I don't know, 20 or 40 tons of riprap on an eroding bank this winter. And that is actually a management strategy by landowners, because although we had a bank stabilization plan already drawn up and essentially approved by all the agencies, and it's been sitting on the shelf for a couple of years waiting for implementation, the landowner waited until the emergency occurred this winter and then called up the riprap company and did what he wanted to do. So waiting for emergencies and then acting under emergency rules where you don't need to go through environmental review is a management strategy for streamside landowners that's invoked all the time.
Without consequence.
Yeah, because it's an emergency. So if you can predict something's going to happen, I'm not sure it's an emergency, but nonetheless, that's the way it's often done.
Hi, I'm wondering if you could say a few words about climate change and how, in particular, how climate change, or how the latest climate change science is affecting the management activities of NIMS and other organizations.
You know, I don't know that it is changing our management activities, other than we're certainly all aware of it, and there's some expectation that we address climate change in any analysis and any documents we write. I think our agency is working on sort of a unified science position on climate change that we will try to implement nationwide, rather than each region trying to do their own. But we're a little ways out on that. Yeah. But you know, if the models are any good, it shows that it's going to our areas are going to get drier, and the droughts are going to be more frequent. And it's all the more important that we get into this process of really getting serious about water management in the face of climate change. Yeah.
So I don't need the razor anymore. And I don't think any of us do, because
You're happy?
Yeah, you've totally sold us on this idea of water catchment on our rooftops. So what we need now, I guess, all of us, is the next step. Where can we get kits? What other resources do we have? Is there going to be nonprofits or government funding for this sort of thing?
Yeah, I don't know.
Oh, come on now. You suggested this as a viable solution. You've got to have some more sources for us.
I'm just the idea guy.
Yeah, there are a lot of resources on the internet, and I even noticed the local, like a Home Depot type place, giving little seminars on how to set it up and selling products for home rainwater.
I know Santa Rosa, and I think the city of Sonoma, probably going on down here too, in one of your cities. San Francisco is, yeah, is helping people buy tankage, storage for water. And
actually teaches rainwater catchment and gray water reuse workshops. And Santa Rosa has just started to have a rebate program for gray water. Thank you.
so the idea is mainstream.
Where'd you get that map?
We made that map. Yeah, our GIS lab worked on that. It's the rainfall map modified by potential for a 1,500 square foot roof to produce 100 gallons a day.
I have a quick question about that map.
Where are you? Oh, okay.
It's saying that it can sustain like 100 gallons a day, so that's like supposed to be how many months, like for a family or something? I was just wondering, is it taking into account ag water? So like, I don't know, the way I look at that map, it's like the dark blue areas, you should be able to like live in your house and not need any other water, but is it taking into account like the water you would need to like raise crops and that kind of thing?
No, it's just 100 gallons a day. So you could use that to take one shower.
Yeah, so it's not taking food.
Or you could use it
to
to irrigate your artichokes and take a short shower.
Okay, thank you.
You know?
I think we have time for one more question.
Got one right there.
Okay, I'm going to pick somebody who has asked one yet.
Okay. I guess going back just to revisit the bank repair this winter on the Russian River, I think that landowner may have been held up quite a while in the permitting process through there. And I think if we're having difficulties with the mechanisms for permitting at the bank protection scale, what's the framework for doing this reach-wide or watershed-wide restoration that you spoke of?
Yeah, great point. Do you have some familiarity with that project, by the way? Do you? It wasn't my understanding that they were held up for permits in that bank stabilization, but nonetheless, that does happen. No doubt about it.
Been with the county for over a year, is my understanding.
But that bank stabilization could be permitted separate from that.
Okay.
Yeah, definitely. The EIR is for the next phase of gravel mining in that reach of the Russian River. A whole different can of worms.
But
yeah,
still, it's difficult.
It is. You bring up a good point.
DFG, it's difficult to permit a bank stabilization,
Yeah.
even if it's a biotechnical state.
Yeah, no, you bring up a good point, and I think the agencies are remiss at managing reaches. We manage individual project proposals that come in our door. Well, that piecemeals all the problems, that doesn't even recognize physical processes, it doesn't recognize the linkage between watersheds and streams, but it's the way the laws are written, it's the way the bureaucratic organizations are organized. But this EIR you just mentioned on the Russian River, the reason it's taking a long time to get that finalized and approved is because it's novel. It incorporates bank management and habitat enhancement in under the umbrella of a gravel mining plan. And that's never been done before. So that affects a 6 or 7 mile reach of the Russian River, and it's worth taking a long time to do it right.
And how about the broader scale? Do we have a framework to do this watershed scale restoration? It's moving towards these programmatic agreements, things like that.
No, I don't think we have a vision for how to do that. I think that's because we haven't really recognized the scale of the problem yet.
Okay, thank you very much. Let's thank Dr. Kluwer one more time.